Good morning, good evening, good day, guys. I hope you're fine and welcome to this module 4. And in this module, we're focusing on data structures in Python. So we have 6 subcategories which we'll be covering in this module. So subsection 1 will entail list, and we'll have to look at list indexing, list slicing, list methods. And subsection 2 will look at tuples, which are immutable sequences. And subsection 3 will be dictionaries, that is key value pairs. And subsection 4 covers sets. We look at unique collections and set operations. And in subsection 5 we're going to look at stacks, queues, and deques. And finally, subsection 6 we're going to work with collections module. The main agenda is to make you more practical than more theoretical guy. So let us head to VS Code and start our magic. Welcome again, guys, to module 4, and this module is going to cover data structures in Python. So this module I will cover list, tuples, dictionaries, sets, and specialized collections from the collection module. Each section will include practical examples and performance notes. So part 1 we are going to look at list. Lists are immutable as sequences, so which means you can modify them after creating them. So lists are ordered, mutable collections that can store heterogeneous data types. So heterogeneous means different kinds of data types. So we need to look at basic list operations, and we start with the symbol example colors is equal to red, green, blue, and yellow. And we want to do indexing. So remember, Python indexing is 0 based, which means the first element starts from 0. So if we want to print the first element, for example colors at index 0, we'll get the red. And if we want to get the last element, and we have to index as -1, which will get the color as yellow. So moving ahead, slicing, pseudocode is we start, we stop, and we step. So first we want to print the first two element of the colors, so we'll get as red and green. And we can also print by 2 steps or any other steps as we want. So in this case we're printing red and blue. And we can also print in reversal order by using colon colon -1. And this is the output. So we need to note that slicing will create a new list which we call a shallow copy. So we're going to look at essential list methods, and we start with how to modify a list. So for example, list of colors we have just worked on previously: red, green, blue, yellow. So colors.append, so we want to add color purple, so it will be appended at the end or to the end of a color. So you can also insert, but insert we need to start with an index where our new object will be inserted, and we're inserting at index 1, which means it will push green ahead. And colors.remove green, for example, which means the green stuff will be removed, or the green color. So you can also get the popped color. We can pop out the color at index number 2, which means we are removing blue. We can also print the modified list of colors, so we get output of the modified list after doing all our magic. So remember, green is not there because we had removed it. So information on methods. For example, we need to print the index of color blue. So colors.index blue, so it will give us as index number 2 based on our colors. And you can also get the count of red. You say colors.count and then red. You get the red is only appears only one time. You can also get the length by getting using the length function, and we pass on our argument, which is color, and you get the length as 4 because you have 4 colors: red, orange, yellow, and purple. You can also sort our list, and if we use colors.sort, which means it will just sort in place and nothing will happen. So we can also do reversal, which means colors.reverse, which means we will start now from the end to the beginning. If we print our colors, we get output as yellow, red, purple, orange, and blue. Remember, we said lists are ordered, so it will be ordered in alphabetical order. And now this is a warning that modifying list while iterating can cause unexpected behavior, so be very keen while operating on lists. We're going to look at tuples. Tuples are immutable sequence, so which means that once we create tuples, we can't modify them, as you can do the same to list. So they're opposite to list. So tuples are ordered and immutable, which means cannot be changed after creation. And we want to look at tuple basics, just as we've looked at list basics. So for example, we have dimensions is equals to 1920 and 1080. So that's the screen size, for example, and RGB red color is equals to 25500. So if you want to access the element from the dimension of a tuple, we still do the same indexing as we've been done on the list. So with the, you can say, dimension at index 0 and red component RGB red at index 0, you still get the red color. So you can also do packing and unpacking. For example, x and y is equal to dimensions. So what is 1920 will be x and 1080 will be y. So and the same we can do tuple packing. So coordinate is equal to x, y, which means it will be given x to y accordingly. So we need to note that single element tuples need a comma or singleton. That is, for example, 42 comma. So if you don't use a comma, it will be taken as a character. So and we need to know when to use tuples. So tuples are used in two ways. One as for fixed collection. Example, days of the week can be days of the month, days of the week or months of a year, so and so on and so forth. So and B, it can be also used as a dictionary. We're going to look at one example. For example, we want to look at locations, and it's a dictionary of having some coordinates like this one for Tokyo and 47.71, negative 74.01 for New York City. So if we print location, we find that Tokyo and New York are assigned those coordinates. So and C, tuples can be used for function return multiple values. For example, we want this function to return some statistics. So we want to return numbers such as numbers as arguments, and we want to return the minimum number, the maximum number, and the average, or the let me say average number of this computation. So and we get the average number to be for this list of sequence. You get that minimum number is 4, as can be seen, maximum number is 8, and when you compute the average, we must get 5.1666667. So let me run py data structures.py, and you get that the minimum value or the minimum number is 3, The maximum number is 8 and the average value is this one, corresponds to this one, this value 5.1666. Welcome guys to subsection 3, and we are going to deal with dictionaries. Dictionary just key value pairs. So dictionaries store unordered key value pairs with some fast lookups. So we are going to look at dictionary operations in the following sections. So we are going to start with student information. For example, name is equal to Chris, age is 22, and courses are math and physics. So we want to see how we can access some values from the dictionary of students. For example, you can print the name of the student and we'll get the error, a key error if the key does not exist but we are trying to access it. And the age of the student is just student.get age. So it will give us or it will return the age of the student. And you can also print the grade of the student, which is still student.get grade, and default is not applicable. So we can also modify student dictionary, such as you can add an email as chris@un.edu. So it means adding or updating a dictionary. So you can also delete a dictionary by using del keyword student age, which means we are removing a key of age. And now courses, you can pop out the courses, which means we are removing the courses. The student is not assigned to any kind of course. So you can also do what we call dictionary views. For example, we need to print dictionary dot keys. So we want to see all the keys from the dictionary and items as well. So student dot items. So if we print this, we are going to get all the items associated with the student and all the values associated with the student. And we're going to look at dictionary comprehension. And remember, comprehension is just a concise way to work with dictionaries, and the same applies to lists, the same applies to tuples, and so on and so forth. So for example, we want to calculate some squares using dictionary. So for example, x is being mapped to x squared for each value of x in the range between 1 and 6. So that is value from 1, 2, 3, 4, and 5, because 6 will be excluded. So if you print the squares, we'll get as 1 is to 1, 2 is to 4, 3 is to 9, 4 is to 16, and 5 is to 25. Let me expand my terminal and rerun py data structures.py. We get the name of the student is Chris, the age is 22, grade is a nay, not applicable, and we have keys, and we have our dictionary keys. You have name and email, and we have dictionary items as name Chris and email chris@un.edu. And we have our last stuff, what we did on comprehension is here. 1 is to 1, 2 is to 4, 3 is to 9, and 4 is to 16, and 5 is to 25. So let's move ahead. Welcome again, guys. In this subsection 4, we're going to look at sets. So sets are just unique collections, which means you don't have duplicates in sets. So sets store unordered unique elements with first membership test. So we have set operations in the following sections. For example, prime numbers is equal to 2, 3, 5, and 7. So even values is equal to 2, 7, sorry, 2, 4, 6, and 8. Remember, sets also starts with the curly brace like dictionary, but it's not a key value pair. So you can do some basic methods like prime.add. We're adding 11 to the element, and primes.discard, we're removing 3 to the elements, and you can also do primes.remove 5. So we've also removed 5 from the prime numbers. So we can do set algebra. So for those with few university knowledge on algebra, here is what a set algebra entails. For example, if you want to find the union of prime and even, we use prime pipe even, so we get all the unique elements without duplicate. So you can also do intersections, which means what is common both in prime and evens. You can also do the difference. So prime minus even, you get what's in prime but not in evens. You can also do symmetric difference of primes using sets. So this one will give us elements in either but both, but not both, which in this case is 4, 6, 7, and 11. So if you run, we expect to get the same result. So note that frozen sets are immutable versions of sets. I believe we've covered that in the previous, I think it was in module 2, if you can reference from what we've just uploaded before. So we were looking at stacks, queues, and deques on subsection 5, and which will be the last subsection on this module. So we are going to look at stack LIFO implementation. LIFO simply means last in, first out. So we are going to have a stack. So LIFO, you can compare LIFO to bricks. So which means the last one that is added is the first one to be taken away. So for example, we have a stack. We want to append task 1, we want to append task 2, and we want to pop out the current task. So which means that task 2 will be taken away. So if you print the current task, so which means that the current task 2 will remain in the session. And we're also going to look at FIFO implementation. So FIFO is first in, first out. You can compare that to a bank queue. So the first in is the one to be first served. So for example, queue is equal to so we are starting with a collection module. So from collections we need to import the queue, and queue is equal to the queue. For example, Francis at Andrew. These are the people on the queue. So queue.append, now we want to insert another member or another customer, Charlie. So the next person will be queue.pop left, which means we are dequeuing the line, which means we are serving another client and making sure that our line is being emptied. So if we print the next line or the next person, you get that one will be Francis. And note that for queues, the queue is more efficient than list.pop, and we're going to see some explanation here. So list.pop, we need to compare time complexity 0n, which means linear time, and this is why when you do pop-up on 0 indexing on a list, it removes the first element but shift all the remaining elements one position to the left, which means every other element will be affected. So this takes linear elements. This makes sure that all elements are affected. So whereas collection.deque, if you consider on time completion, we realize that a deque or double-ended queue is optimized for append and pop operations on both ends. So it uses a doubly linked list or a similar structure under the hood. So it can be removed or so it can remove at the first element without shifting the rest, because operations can happen on both ends, unlike what's happening in list. For example, from collections we import the queue, and now using the queue, let us have a queue as the queue as a list of 1 2 3, for example, for 3 individuals in a line. So we want to pop from the left, which means that I want to remove one person from the left, so we remain with 2 individuals. So, and if we use a list, we just use pop, which means the last element will be removed, and which means that all the people on the line will be affected, which will be forced to move one step ahead or one step behind. And we're going to look at specialized collections. So we are going to import a counter from collections, and also going to import default dictionary. So don't worry about these modules. With time they'll be your second nature. And moving ahead, we're going to look at counter. So that's multi-set counter. And we're going to work on an example in inventory. So counter, for example, we have 5 apples and 3 oranges. So inventory.update, we say apples and bananas. So we need to increment the counts. So if we print the inventory, we get the output as apple as 6, oranges as 3, and banana as 1. So in this example, we're going to look at word count. So for example, for word in hello, world, and hello. So word count, word plus 1, so which means we're incrementing, so which means no key error for new words. So we also need to print word count, and we provide word count as our variable. So output should be word count, and default will be class int hello 2. So since hello is appearing twice and word is appearing a 1, so if we run our program, we realize that hello will appear twice and word will appear once. So if I run my program py data structures.py, you find that at first instance it appeared once, hello appeared once, at second instance it appeared once, so it has automatically added the instances of hello, and you get it as 2. So word appeared only once at all searches. So, and this is the final stuff. So let us move ahead. Again, welcome guys, this final section of module 4, and we're going to look at named tuples, that is self-documenting tuples. We are going to have an example. Point is equal to named tuple, point x and point y. So p is equal to point 11 and y is equal to 22, and you can print the point of the coordinates p dot x comma p dot y, which means output will be point coordinate to be 11 22. And now we can have our summary from all our stuff, that lists are immutable sequences, whereas tuples are immutable sequences, and dictionaries are key value mappings. And on the other hand, sets allow only unique collections, and stacks / queues allow LIFO and FIFO structures, and collections on the other hand allow specialized container types. So our module 4 is complete. So your data structure toolkit is now well equipped. So let us meet in module 5, and kindly please subscribe to our channel. Thank you.